In this example, we're going to algebraically determine the x-intercept and y-intercept for two different linear equations. To start, we want to recognize that that x-intercept is going to occur when the y value is 0. We saw that in the graph in a previous example. So, algebraically, I'm going to write down that the x-intercept is where y equals 0. So if I want to algebraically determine that, I'll replace the value of y with 0 and solve for x in my equation. So doing that, this first equation is 2x minus 5y equals 20. So I'll take 2x minus 5 and I'll replace that y with 0 and I'll set that equal to 20. Simplifying now, I find that 2x is equal to 20. And so dividing each side by 2, that will make x equal to 10. So the x-intercept is the point 10, 0. The y value is 0 for that x-intercept, and we found that the x value for this equation is 10. I'm going to come over to the make a right column over here, and now I'm going to find the y-intercept. So remember that the y-intercept occurs where our linear equation intersects that y-axis, and again that's going to occur where the value of x is 0. So to algebraically determine that, we'll take our equation 2x minus 5y equals 20 and we'll replace x with 0. So we'll have 2 times 0 minus 5y equal to 20. And now simplifying that, 2 times 0 is 0. So 0 minus 5y is going to equal 20. And I wrote that extra step because I have to make sure that this simplifies down to negative 5y equals 20. That's a key step there to not miss. And then after this, I'll divide each side by negative 5. And so I'll get that y is equal to negative 4. So to summarize that, the y-intercept is the point 0, negative 4. For this second equation, we're going to do the exact same process. Here we have an equation y equals negative 3x plus 5. To find that x-intercept, again remember that the x-intercept occurs where, for a linear equation, where that linear equation intersects that x-axis. And so what's true there then is that the value of y is 0. So now, working with this equation y equals negative 3x plus 5, I'll replace y with 0. So I'll have 0 equals negative 3x plus 5. And now solving this equation, I'll determine the value of x that occurs at that x-intercept. So subtracting 5 from each side, I'll get negative 5 equal to negative 3x. And then dividing each side by negative 3, I'll find that 5/3 is equal to x. So the x-intercept, and that's going to be a point where the x value is 5/3, so it's the point 5/3, comma 0. Lastly, we'll calculate the y-intercept for this linear equation. And again, the y-intercept occurs where we intersect that y-axis. And what's always true when that happens is that x is 0. So we'll take our equation, y equals negative 3x plus 5, and we'll replace x with 0. So we'll get y equals negative 3 times 0 plus 5. And that'll just simplify down to y equals 5. So that tells us then that the y-intercept is the point 0, 5.